Welcome back to Max with RP. In the earlier videos, we have been learning about increasing and decreasing functions. Today, we are going to learn about what is local maxima and what is local minima. What do we mean by these terms? See, suppose you have a graph. This is my x and y. See, I can have a graph like this. Let me restrict my domain to 1 to 10. Let us assume that we are going to study the function in our restricted domain, which consists of real numbers from 1 to 10. Okay. So let me mark this as 3 and 4. Okay. 3.5, etc. See, we have already studied about increasing and decreasing functions. Okay. So if you look at this graph, you know that the function is increasing here. To the left of 2, it is increasing. To the right of 2, it is decreasing. So if I draw an horizontal tangent at x equal to 2, it is going to be parallel to x-axis. Okay. So when you have a function which is increasing and then decreasing, slope is positive, so it is increasing, it is decreasing. Again what happens? It is decreasing, increasing, then again decreasing. These 3 points have slope equal to 0. So if m is 0, where m is the slope of the tangent line. Then you can see here also m is 0, here also m is 0. Okay, now if a function is increasing and then decreases, okay, then at 2 is the point where if I draw an horizontal tangent, when x is 2, if I draw an horizontal tangent to the curve, then the slope of the horizontal tangent is 0. Then we say x equal to 2 is a point of local maxima. If you want to remember, you can always remember like mountains and valleys. Okay. So this is x equal to 2 is a point of local maxima. Again, this is increasing and decreasing. So x equal to 7 is also a point of local maxima. What happens at x equal to 3.5? It is decreasing and then increasing. So when the function, the graph of the function is decreasing and then increasing, there also the slope is going to be 0. Then we call this point at x equal to 3 is a point of local minima. X equal to 3.5 is called as a point of local minima. Why it is, we also call it local minima? You can already see there are 2 places where the horizontal tangent is parallel to the x-axis and the graph increases and then decreases, increases and then decreases, both at x equal to 2 and x equal to 7. So both of them are points of local maxima. Okay. Whereas x equal to 3.5, you can see that it decreases and then increases. Then x equal to 3.5 is called as a point of local minimum. So I hope you have understood what is the meaning of local maxima and what is the point of meaning of point of local minimum. Even before we explore these concepts more, I want you also to understand intuitively that we can talk about maximum value and minimum value, okay, when you are defined a function like this, and I may not even need to use calculus for that. See, for example, I want to find without derivative the maximum and minimum value of modulus of y equal to modulus of 2x plus 3. Where x belongs to the closed interval -7, -2. Okay. Now, what is the meaning of this? -7 is a closed interval. So, less than or equal to x, less than or equal to -2. I want 2x plus 3. See, this is for x. But I want to explore about 2x plus 3. So, 2x will lie between -14 less than or equal to -4. Then let me add 3 to the inequality. So I will get -11 less than or equal to, what I have done, I am adding 3. So -4 plus 3, which is -1. Then I want to find actually the modulus. Okay. So modulus of 2x plus 3 will lie between what? When I take modulus, this will become 11 and this will become 1. So minimum value is 1 and maximum value is 11. So I have not used calculus, I have just used the concept of logic and inequalities, okay, to find out what is the maximum and minimum value. So it lies between 1 and 11. See, actually 1 less than or equal to modulus of 2x plus 3 less than or equal to 11. When I take the absolute value sign, right? So the minimum value is 1, the maximum value is 11. Now here -2 less than or equal to x less than or equal to -5. Okay. Now I want to actually find, this is the relation for, this is the inequality for x. I want minus x. So minus x will be greater than or equal to 2, greater than or equal to 5. Then I want 4 minus x. So 4 minus x means I am adding 4 here. So if I add 4, I will get 6. 4 plus 5, 9. I am adding 4 throughout. So this becomes 4 minus x, this becomes 6, this becomes 9. This is the range of values of x which is given to you. -2 less than or equal to x, less than or equal to -5. Okay. Now modulus of 4 minus x will be, if I take modulus, I will get 6 greater than or equal to modulus of 4 minus x greater than or equal to 9. This -2, so 4 greater than or equal to modulus of 4 minus x minus 2 greater than or equal to 7. So smallest value is 4, the biggest value is 7. So minimum value is 4, maximum value is 7. So are you able to understand how with the help of inequalities you can establish the minimum and maximum values sometimes without even using the concepts of calculus? Now look at this. Here x is the entire real set of real numbers. So the domain is the entire set of real numbers. And f of x is 10 minus x minus 1 the whole square. You know that x minus 1 the whole square, being a square, has minimum value of 0. Say x minus 1 the whole square can never be negative. So the minimum value it can have is 0. Okay. So when x minus 1 the whole square is 0, f of x is 10. So maximum value of f of x, because it is 10 minus this, maximum value of f of x equal to 10. Are you able to follow? The maximum value of f of x is 10. Minimum, it can be anything, because x minus 1 the whole square can be 1000, can be 20,000, can be 2 lakhs, right? So this will become smaller and smaller. So minimum value does not exist. So 10 minus x minus 1 the whole square, the maximum value is 10, the minimum value does not exist. In fact, we can look at this in the GeoGebra also. See, we were exploring algebraically what is the maximum and minimum values of y equal to 10 minus x minus 1 the whole square. Okay, you can easily see the maximum value is 10. Only you can only tell the maximum value. Minimum value you cannot tell, it cannot be determined. So this is because it's a quadratic, you also know it is a parabola, and the maximum value of the parabola is 10. So how did we determine? Because the minimum value of x minus 1 the whole square is 0. Okay, so it is because x minus 1 the whole square is a positive quantity. It's a positive quantity greater than or equal to 0. So maximum only is 10 and minimum cannot be ascertained for such a function. So this is what we saw in the GeoGebra screen. Now look at finding the maximum and minimum value of sine 2x plus 5. This is very easy, and I'm sure that you have used it while you were finding the domain and range of functions. So this process is similar to that. So minus 1 less than or equal to sine 2x less than or equal to 1. We want sine 2x plus 5. So sine 2x is less than or equal to 6. So the minimum value is 4 and maximum value is 6. So are you able to follow how to find the minimum and maximum? So if you take here x in R, we know that sine 2x lies between minus 1 to plus 1. I have added 5. Sorry, here this should be sine 2x plus 5. Okay, sine 2x plus 5 will be add 5 throughout. 5 minus 1, 4, 5 plus 1, 6. So sine 2x plus 5 lies between 4 to 6. So minimum value is 4, maximum value is 6. Now look at this problem. F of x equal to 9x square plus 12x plus 2. Okay, we have y equal to 9x square plus 12x plus 2. Now this is, I can write it as 3x the whole square plus 2 into 3x into what is remaining 4 plus, so are you able to follow this 12x I have written as 2 into 3x plus into 4. Okay, so I have to add, see already I have 2. This 12x only I have written as 2 into 3x into, into 2. Okay, then, so this is of the form 3x a square plus 2ab, where b is 2. So b square I should add. So I should add 4 and subtract 4. Okay, so that is y plus 4 is equal to 3x plus 2 the whole square plus, what will you get? 3x square is 9x square plus 4 I have written here This minus 4 I have included. So this is 3x plus 2 the whole square. This is the form a square plus 2ab. So 3x plus 2 the whole square plus 4. Okay. Then what do I have? What am I left with? This is 9x square plus 4 plus 12x. Okay. So to complete the square, I have added 4. So I have to subtract 4. That minus 4 I have taken here. So 4 plus 2 will be 6. Are you able to follow? Now y plus 4 is equal to 3x plus 2 the whole square plus 6, or y equal to 3x plus 2 the whole square plus 2. Now we want to find out about only this. 3x plus 2 the whole square is a square. So minimum value of 3x plus 2 the whole square is 0. Okay, so when 3x plus 2 the whole square is 0, y will be 2. So the minimum value is 2. Okay, that is minimum value is 2. Maximum cannot be said, cannot be determined. Because I can keep on adding, no, 3x plus 2 as I give different values of x. 3x plus 2 is going to become bigger and bigger and bigger. So y will also become bigger and bigger and bigger. So it's unbounded on the maximum side. So minimum value is 2, maximum cannot be determined. So what are we actually looking at? 9x square plus 12x plus 2. So let us look at the GeoGebra part of it. So we are looking at 9x square plus 12x plus 2. Look at the graph. Okay, so sorry, 12x plus 2. So this is a graph of 9x square plus 12x plus 2. Okay. So when I put y equal to, so how do you check whether the graph is correct? When I put, this is y. Okay. When I put y equal to 0, that is when x is 0, y should be 2. So does it cut the y-axis at 2? Okay. Now we did the completion of square. Okay. You had y equal to 3x square, 3x plus 2 the whole square. What will I get? 9x square plus 4 plus 12x plus 4. So I have to add 2. So this becomes 4. If I have 2, I have to add 2 here also. So y plus 2 equal to 3x plus 2 the whole square plus 4. Or y equal to 3x plus 2 the whole square minus 2. Okay. So what is the value of x for which y is max? So this is what is the minimum value of this? Minimum value of this square alone is 0. So minimum value of y is minus 2. So you can see it is minus 2. So the minimum value is minus 2. Okay. So for what value of x, y is minus 2? When I put y equal to 0, I can find x. and I can find out for what value of x, y is minus 2. So this value of x will give you, if I want, I can write down the point of intersection. Have you understood this? So if I use this point of intersection, you can see it is almost minus 2, minus 0.64. So when x is minus 0.64, you have the minimum value of minus 2. Okay. Therefore, I hope you have understood a little bit about how to find maximum and minimum values without using calculus. Because from in my next video, I'm going to introduce how to use calculus to find local maxima and minima, and later on to find absolute maxima and minima. But before that, we need to develop an intuition about what is maximum and what is minimum. So this is just an introductory class about developing an intuition about minimum and maximum. Okay, so until we meet next time, it's goodbye. I hope you found this video useful. Thank you.